Hi everyone. So we'll do some questions based on our instantaneous rate because average rate I think enough practice has been given. So just a quick revision, we studied about graphical representation, right? The reactant concentration is decreasing. So we are drawing the graph like this, and how do we find the slope? Slope will be equal to tan theta. I have drawn a slope here. Now I told you a trick how to find the positive slope, right? Put your left hand in that direction where you have put a tangent. Whatever side your upper part of the hand is coming, that side is your positive slope. So here, like in your um, first graph of reactant graph, your positive is coming on this side. My upper part of the hand is coming on this side. So this one will be positive slope. Slope will be equal to tan theta. Tan theta will be equal to dr by dt. Similarly, here in product, I've kept a slope like this and my positive is coming this side, right? So it touches here. So my slope will be dp by dt. So based on this, we'll do some questions and I hope it will be clear for everyone then. Okay. We'll do some questions based on our instantaneous rate means we need to find at an instant. So the equation tells you N2 plus 3H2 is giving me 2NH3. You have a graph given here, and in graph you have concentration of H2 with respect to time. You have the number 6 and 10 here, you have the number 2 and 4 here. This is how the graph is given, like just put a proper crescent here. Yeah, what you need to find, you need to find your rate of reaction and your rate of disappearance of N2. These are the two things which you need to find. Now from the reaction, first write the full equation. How do you write the rate of reaction? The rate of reaction, now you all should be very fast in writing the rate of reaction. This one will be minus delta N2 by delta T. I think this one will be minus 1 by 3 delta H2 by delta T. I think this thing will be D, right? Why D? Because you are finding instant rate. So instead of delta, we just need to write minus of delta dN2 by dt, which will be equal to minus 1 by 3 dH2 by dt, and this will be equal to plus 1 by 2 dNH3 by dt. Now what thing is given to us? You see, in the graph you have H2 values, right? So we need to do something wherein we can find this particular thing to find the rate of reaction. This is equal to your rate of reaction, right? So how will we find it? dH2. What is H2? Like, how do you find this thing? dH2 by dt will be equal to your slope. What is your slope here? Slope equals to tan theta, which is change in y-axis by change in x-axis, right? So y2 minus y1 divided by x2 minus of x1. This is your slope, correct? So y2, what is your y2? y2 is your 10 minus 6 will be divided by 1 minute. This one will be your y2, right? This one will be because see, it's starting from here. So starting from here means this one will be my y1, this one will be my x1. And then it's coming here. So this one will be my y2 and this one will be my x2. So what is your y2? y2 here is 6 minus 10 divided by 4 minus 2. Minus 4 by minus 2. No, not minus 2, 2, which is equal to your minus 2, right? So this is what you have got for dH2 by dt. Now how do you find the rate of reaction? Just substitute this value here. So this one will be minus 1 by 3 into minus 2, which will be equal to minus minus becomes plus 2 by 3 moles per liter second inverse. This is how you write the rate of reaction. Now what they have told us to find? We need to find the rate of disappearance. Just equate these both. So 2 by 3, which we have find the rate of reaction, will be equal to 1 by 2 dNH3 by dt. 1 minute, rate of disappearance of N2, this we need to find, I'm so sorry, d by N2 by dt. So this is the same thing only, no signs is needed, so 2 by 3 moles per liter second inverse is your answer. Next question, similar question, try it on your own. The question tells you 2p plus 3q, 2p plus 3q is giving me R. And they have given us a graph for Q. So now it's a single graph, okay. Q by time, this angle is given to you as 45 degrees. Just remember my trick to find the positive slope. So what we need to find is rate of reaction, and second thing which we need to find is rate of appearance of R. Now how do we find it? First write the full reaction. How do you find rate of reaction? Rate of reaction equals to minus of 1 by 2 dP by dt, which is equal to your minus 1 by 3 dQ by dt, which is equal to your 1 by 1 dR by dt. Now how do we find it? What thing is given to us? Q is given, right? We can find this particular thing, dQ by dt. What will be your dQ by dt will be? Slope. What is your slope? Slope will be equal to your tan theta. What is tan theta? Now will you take tan 45 or your this angle? How do you get to know? I told you one thing. Put your left hand in the direction of the line. Whatever side the front side is coming, that is your positive. So this one will be positive, right? So 180 minus 45. What will it be? 135. So this will be 135 degree. So you need to find tan 135 degree to get the answer. What tan 135 degree is minus 1. So now just substitute this particular thing here. So rate of reaction will be equal to your minus 1 by 3 into minus 1, which will be equal to 1 by 3 moles per liter second inverse. Okay. How do we find the rate of appearance of R? Just relate this and this. So rate of reaction will be equal to your dR by dt. And we just need to take the mod of it. So this thing will be same, 1 by 3 moles per liter second inverse. How do you find the rate of appearance of P? Just a additional question. Rate of appearance of P. Equate then these both things. Equate these both. So 2 times of ROR will be equal to your dP by dt, which is equal to your 2 by 3 moles per liter second inverse. This will be your rate of appearance. Last question based on the graphs. Now the question is telling you 2a plus b is giving you c. 2a plus b is giving you 3c. And the graph they have given is this. The tangent, they have made a tangent here and the angle is 30 degree here. And the graph is between B and time is here 5 seconds. So what you need to find? you need to find the rate of reaction at 5 seconds and rate of disappearance of A at 5 seconds. How do you find the rate of reaction? Same thing. Rate of reaction will be minus of 1 by 2 dA by dt, which is equal to minus 1 by 1 dB by dt, which is equal to a plus 1 by 3 dC by dt. What do we have? We have this particular thing. What will be dB by dt? Will be equal to your tan theta. Now, what will be theta? You cannot put your hand like this, right? You have to put your hand like this. So, tan theta will be, here it will be 180 minus 30. What is 180 minus 30? 150. So, tan 150. How do you find tan 150? Just do tan 180 minus 30, which will be equal to your 1 minus 1 by root 3. Tan 150 is minus 1 by root 3. So now what will be your rate of reaction? Your rate of reaction will be minus of 1 by 1 into minus of 1 by root 3, which will be 1 by root 3 moles per liter inverse second inverse. Then we need to find the rate of disappearance of A. Rate of disappearance of A will be this particular thing, right? So 2 times of ROR. So this thing will be 2 times of root 3 moles per liter second inverse. Also you need to find now supposingly rate of appearance of C. What will be rate of appearance of C here? 3 times of ROR. So this will be 3 by root 3 moles per liter inverse second inverse. Okay, so this is how you do all the kind of reactions, all the kind of questions based on your instantaneous rate and average rate. Okay, just remember for rate of appearance, rate of disappearance, we don't consider the signs. Okay, next topic which we need to study is factors on which rate of reaction depends. Factors on which your rate of reaction will depend. The first factor is the nature of reactant. First factor is your nature of reactant. What is nature of reactant? What kind of reactant it is? Whether it's an ionic reactant or your covalent reactant or your homogeneous, heterogeneous reaction. Like there are a lot of things. Nature of reactant. First thing in this, whether it's an ionic reactant. See, what are we doing? We are actually finding the speed of the reaction, right? Now, if you have ionic reactant, your ions are already present in it, right? So, the reaction will be very fast. Like for example, you have NaCl plus AgNO3. Ions are already present in the form of Na plus, you have Cl minus, you have Ag plus, you have NO3 minus. Ions are already present. In movement of ions and all and forming your precipitate, it will be comparatively very easy, right? So, in place of ionic reactant, wherever you have ionic reactants, the rate of reaction will be comparatively high. Secondly, if you have covalent reactants, like covalent bonds are there in between them, so rate will be comparatively lower. Rate of the reaction will be comparatively lower. For example, you have N2 plus 3H2 is giving you 2NH3. See here your bond is breaking and your bond formation is taking place. So it takes time to break the bond and form a new bond. So the covalent reactant, wherever it is present, it means it will take some time. It will take some time, so rate of reaction will be comparatively lower. Third thing which you have to keep in mind for rate of reaction is your homogeneous and heterogeneous reactant. Homogeneous and heterogeneous reactant. Definitely your homo will be greater. The homo's reaction will be greater than hetero because it's in the same phase, right? It don't have to do any kind of polarity change, any other different kind of changes. So wherever homo reactant is present, that will be more, rate of reaction will be given more. The fourth thing which you need to notice is the rate of reaction will be directly proportional if the stability of product is high. What is our main goal in any kind of reaction? To get the products, right? Wherever your stability, wherever your formation of product will be higher, that way your rate of reaction will be higher. The stability of product will be higher and inversely proportional to your stability of reactants. Okay. Example, you have CH3COOH. Now you are getting here CH3CO minus and H plus. I am writing two reactions here. This is my first reaction. Second reaction is HCOOH is giving me HCOO minus plus H plus. This is my second reaction. Now just apply your general organic chemistry or GOC and find out which one will be more stable, CH3COH or HCO minus. See, for CH3COO minus, CH3 is your electron donating group, right? Increasing the CO minus charges here. So here comparatively your stability is decreasing. Stability decreases. But here if you check for HCOO minus, it doesn't have even plus I or minus I. So wherever your product stability is higher, that side your rate of the reaction will be higher. This is how we find for nature of reactant. The second thing is physical state of the reactant. The second factor which you need to, first thing was nature, second thing is physical state of the reactant. Physical state of the reactant. Here your gases will have more chances of collision, right? You already know this, gas, liquid, then solid. So wherever gases are present, your reaction will happen very strongly, very firmly. The third thing is, I think this is self-explanatory for physical state of reactant. The third thing is surface area of reactant. Surface area of reactant. Now this factor is only spoken for solids because that solid is only having surface area, right? For solids only. And here the rate of reaction depends upon your surface area of reactant. Whatever is having more surface area, that thing will have, like, that reaction will take place fast. Now for example, if you take sugar granules and sugar powder, you are taking sugar granules, and next thing which you are taking is sugar powder. Which one will dissolve the fastest? The sugar powder, right? Why? Because it has more surface area. So that's how it depends upon the surface area. Next thing is intensity of light. Now some reactions are very photosensitive, right? So as you increase the light, the reaction rate increases. Example is your photochemical reaction of H2 plus Cl2 in the presence of H nu. H nu is your photon, is giving me 2HCl. So as you increase this particular light, the intensity of light, the number of photons is increasing. Number of photon increases and thus your rate of reaction also increases, right? So first thing was nature of reactant, second thing is physical state of the reactant, third is surface area, fourth is your intensity of light. The fifth thing is Catalyst. Now you know in some cases catalyst speed up the reaction. What does catalyst do? It speeds up the reaction. Second thing is it speeds up or down, both thing it do. Or set up the alternate path for the reaction. Sets up the alternate part of the reaction. Like how does catalyst work? You have an energy. So reactant is converting into product. If you are using catalyst, it will go through lower activation states. Okay, activation energy without catalyst. For example, if you have SO2 plus O2 is giving you SO3. So, like it takes place suppose in 10 minutes. Like just a random figure. Now if I introduce a catalyst into it, catalyst of NO, the reaction will take place very fast, maybe 5 minutes. Okay, that's how your catalyst take part in the reaction. Next is your temperature. What happens for temperature? Generally what happens is the rate of reaction, in maximum cases the rate of the reaction will increase as temperature increases. Like usually it's told on 10 degrees Celsius rise in temperature. On 10 degrees Celsius rise in temperature, your rate of reaction will increase approximately 2 to 3 times. Okay, then the last point and very important point is concentration of reactant. Very important point. Concentration of reactant. See, this is very confusing. Why? Because sometimes rate of reaction increases with increase in concentration. Sometimes the rate of reaction decreases with increase in concentration. Sometimes the rate of reaction is not affected by any increase in concentration. And sometimes also the rate of reaction depends on the concentration of product also. And sometimes the rate of reaction depends upon either one reactant or all reactants. So this is very confusing, right? How does the rate of reaction depends upon the concentration of reactant or product is very confusing. So for solving this particular puzzle, there is one thing which is called as rate law. And what does rate law do? It predicts how does the dependence of rate of reaction depends on the concentration of the reactant. So it tells us how does your rate of reaction depends upon the concentration of the reactant or the product. Okay, so rate law will be studying in your next video. So till then, revise whatever we have studied. Okay, so thank you so much.